пока люди не пришли, да, вот я скажу, что вот все знают, кто такой Брюс. Брюс Момжан, один из наших самых первых разработчиков, уважаемый член нашего сообщества, знаю его кучу лет, много лет, и он обладает таким талантом в каждой новой стране, да, начинать чувствовать себя, как будто бы он здесь родился. То есть, скажем, в Красноярске, вот он, мы сказали, он прям чувствует себя, как вот попал в правильное, нужное место. И надеемся, что он будет сюда приезжать. Но самое главное еще, что он, мало того, что хранитель традиций, мы с ним одних из самых таких взрослых членов сообщества, он безумно хорошо читает лекции. Учитесь у него. Недавно он опубликовал блог от 8 ноября, в котором он написал, как надо читать лекции. Вот как я читал лекции, это неправильно. Потому что я делал... I said that my lecture, I did not the right way. But Брюс Момжан читает лекции минута в минуту, секунда в секунду, все просто, ясно и понятно, да. Я, конечно, вот извиняюсь перед вами, что я так занял у вас много времени, но как бы восхитился коллективом и вот, не удержался. Все. Так что встречайте вот Брюса, у него хорошая лекция.
Thank you, everyone. It's really great to be here. I want to thank first Yevgeny for making this conference possible. I was here 2 years ago, and he said, I want to have a Postgres conference in Krasnoyarsk. And I said, actually, this is not on. So, is that okay? Push the button.
А все понимают по-английски, да? Брюс очень хорошо говорит.
So I want to thank Yevgeny for making this conference possible. 2 years ago, he said, I want to have a Postgres conference in Krasnoyarsk. I said, okay, but it sounds really hard. And 2 years later, he did it. So thank you very much. It is not easy to do this, I will tell you. Secondly, I want to thank Oleg and his team of Russian developers who have helped us for years, 20 years, 25 years. Postgres would not be what it is today without our team of Russian developers. And thirdly, I want to thank, who we've talked about already, Vadim Makayev, who 20 years ago made me want to come to Krasnoyarsk because I wanted to see what city produced this very brilliant man. And this is my second time here. Actually, let me ask, how many people heard me 2 years ago? Anybody? Oh, I got some. Okay, great. Oh, good. I do recognize some faces, so I thought, I was like, I remember those people. So anyway, it is wonderful to be back. I know it is late in the day, and I know that English can be difficult, so I will be as clear as possible and as brief as possible. However, I do have, I think, some important information to give you, not only about Postgres, which we've been talking about all day, but the entire software industry. There's a lot of older people who haven't understood the changes that are happening in the software industry, and I think if you can understand what I'm saying today and understand why software is changing and where the software industry is going in the future, you as individuals will be much more effective people because you'll understand where things are going, where everyone else is still remembering what it was 20 years ago. I see that a lot. So that's why it's always nice to talk to young people and of course very creative young people because you're from Krasnoyarsk, so I already know that. And what I wanted to talk about today is a fairly philosophical topic, but I will show you today that it has very practical application. And when you're in the industry and you're given the responsibility of selecting technology or figuring out what technology I should invest in, what skills I should have, where my career should be going, I think this is going to be a very useful lecture for you. Okay. What we're going to talk about in the next 40 minutes or so is the concept of the software life cycle. I know that might be a term you haven't heard before, but the concept of how software is created and how software dies. And I'll be talking about specific examples of that. Then we'll talk about open source. We've been talking about Postgres for a while. Open source is just one example of the many, Postgres is just one example of the many open source pieces of software. And this is the area that I think is dramatically changing. And again, individuals who understand that change are going to be much better off in their careers. Fourth, I'll talk about Postgres innovation very briefly and how some of the ways that Postgres is creative. And finally, we'll just conclude with some smaller points. But again, I understand it's late. I'll go as quick as possible, but also I'll speak as slowly as possible. So there you go. Am I good?
Yeah.
Great. Thank you. So 7 months ago, I was given this topic for this talk. And somebody said, why don't you do a talk about will Postgres live forever? And I was like, that's a stupid topic. I thought, that's a ridiculous topic. Because I thought, okay, the universe is 13 billion years old, and the Earth is 4.5 billion years old, and civilization's been around for only 6,000 years. Okay? So the civilized part of the Earth is tiny, and the digital part of the Earth is... So forever for a piece of software just seemed ridiculous. But I started to see what they were getting at. And I'm going to explain why. Just a brief history. Digital technology is only in the past, well, either 30 years or maybe 100 or maybe 200 years. The first programmable device was a Jacquard loom, 1804. ENIAC was the first programmable computer that was in Philadelphia, which is where I'm from, 1945. Oleg has already talked about E.F. Codd. This is when relational theory started in 1970. 1977, Ingress started at a university, and in 1986, Postgres started at the same university in California. So as you can see, the entire relational time span is only maybe 40, 50 years. So a tiny amount. Forever is a long time. But it has been a very interesting time. 1986 is when I got involved with Postgres. So it's been 22 years now. And I've obviously enjoyed it. I've enjoyed, as part of that, coming to Russia almost 10, 15 times. And I enjoyed seeing many, many of your cities. So let's talk about the software life cycle. Has anyone ever seen a computer like this? Okay, ooh, wow, a couple. All right. So this is the computer we had in high school. We had one computer, and you had to wait your turn to use it. But I just show this image to remind you that hardware doesn't last very long, right? So very few people are still using this hardware. It runs out, it becomes obsolete, it's very hard to upgrade. You wouldn't use this kind of computer anymore. But software has a longer life cycle. As I said before, Postgres has been around since 1986. That's 32 years. And during that 32-year span, it has been continually improved. So while hardware doesn't last a long time, software can last a very long time. But let's start with a different type of software. This is proprietary software, or closed software, or software that's made by a company and you purchase it. So whether this is Oracle or Microsoft or any software that you're purchasing where you don't have any access to the source code and that company's producing the software at some distant location, that is what we call proprietary software. Okay? And proprietary software has a very predictable cycle from its birth to adoption and then ultimately death. And this is a sad, to me, this is a very sad slide, because when I think back of some of the very interesting software that I used years ago that I really loved using, it isn't here anymore. And it isn't here anymore because proprietary software has a very specific life cycle, and it has a death in a way. And I'm going to walk through exactly how this life cycle works. And I think once I explain it, and you think back of software that you've used, it actually makes sense. So, how does proprietary software get created? Well, somebody initially has an idea. I'm going to create new software that does something that no one else does. Maybe it's a game, maybe it's a utility, maybe it's something that's used for banking, maybe it's a middleware or an editor or something brand new. Okay? So they basically start with the idea of innovation. And to implement that idea, that innovation, they have to hire programmers or developers. So software developers are hired, and they go to the company, and they start to write the software. And somebody's paying them every week for them to write the software. Okay? And after a year or 2 years, the software is finally ready to be released and sold. So you enter stage 2, which is what we call market growth. So in this stage, you're basically getting new customers. Okay? So this is a very exciting time. We have new software, we've produced it, and we're selling it like crazy. People are buying it, we have all sorts of orders coming in. This is tremendously exciting. We feel like we're a great success. Look how many people love our software, right? Great, great time to live in. But then you get to stage 3. Because the problem with market growth is that you eventually hit a limit, a stop point. Maybe you capture 90% of the market. Or maybe you capture 30% of the market, and there's some other big company that you really can't dislodge. This big company is too popular. So you have 30% of the market, and you can't really make it any bigger, right? So you've gone from stage 1, when you create the software brand new, stage 2, where you grow the market, and then stage 3, you basically hit what we call a saturation point. You've gone as big as you can within that software market. And once you reach that point, you get to stage 4, which to me is the depressing stage. Because the company has spent a lot of money on stage 1 for those developers for that first 2 years to develop that software. Okay, they poured a lot of money in there. Then stage 2, they've grown as much as they can, but then they reach saturation. So stage 4, they say, we spent a lot of money on this, and we've got a certain amount of customers, and no matter what I do, I can't really seem to get any more money coming to my company. So how do I maximize my profit? How do I get as much money as I can? Well, I can't increase my sales, so I have to reduce my cost. So you start to cut development. You make less money for developers, and you spend less money on support. And the software kind of goes into this slow decline where it's available and people are using it, but it's not really being improved. It's kind of just coasting, and it's getting money from the customers, but it's not really exciting technology anymore, and it really isn't helping people anymore, just kind of maintaining. And once everyone kind of starts to leave the technology for something else, because there's some other new technology that's better and is growing, the software goes into maintenance mode. And in maintenance mode, there are no new features at all, and there's no innovation, and you're basically just the software is just kind of coasting, right? It's just out there. And then finally the software dies at stage 6. So I think of this as depressing because the software probably was really good when it started, but then it kind of just gets stuck. And if you think of the proprietary software that you used, there is a lot of software out there that gets kind of stuck, where they aren't really advancing anymore, and they just kind of go straight, and then eventually they shrink. Now, to contrast that, let's look at open source software. This is software that isn't developed primarily by a company. It's primarily developed by volunteers. Again, I had a lot of help from a lot of people in Russia and outside Russia to help Postgres from 1996 to today to become what it is. Now, when it starts, it doesn't start out with investment. It starts out with just trying to develop some software, maybe for low cost. And we just wanted to do the exact same thing as some proprietary piece of software. Then the market grows, but once you reach saturation, there is no profit maximization, cutbacks, because you don't pay anybody, so you can't cut money, right? You don't make money. So you go into stage 3, where you basically innovate or decline, and then what's interesting in stage 4, the source code is available if somebody wants to continue with the project. Now, in the previous case here, only one company controls the source code, so no one else can really help here. No one else can kind of give it new life. But with open source, somebody can always do that. Now, you might think that's an unusual example, but in fact, Postgres in 1996 was on decline. It was developed at a university, and there was only one person maintaining it, and the releases weren't coming out regularly because he had a full-time job. So in this case, actually, Postgres is one of these cases that went from kind of stage 3, and it went down, and then we got involved, and it went up again. And it's been going up since 1996, which is great. So that's kind of the difference between the two. The proprietary has a very fixed sort of strategy, whereas open source is always available. Now, you might think that's a really kind of stretch, but I'm going to give you a really crazy example. How many people have ever heard of a computer game called Falcon 4? Okay, all right, that's kind of interesting. So the history of this game, I think, very clearly shows you how open source and proprietary software kind of work together. So in 1984, a game company begins a development of a computer game for airplanes called Falcon. Okay. In 1998, they release the version 4 of Falcon 4. So Falcon 4 is developed, released finally in 1988. And in 1999, after a few bug fixes, they stopped development. So if you think of the life cycle of proprietary software, 1999 is like stage 6. So it's stopped, right? They've ended life, it's dead. But in 2000, for about a week, somebody leaks the source code of Falcon 4 to the internet. And within that week, somebody gets a copy. So then a whole bunch of groups of open source people decide that they're going to work on this game as volunteers. And they create a group called Benchmark Sims. And in fact, 2003, they release a version of Falcon with modifications by this community. It's kind of interesting. Then in 2005, a company takes the modifications made by the open source people and they create a new closed source game called Allied Force, which includes the open source modifications from the other group, right? Then that company goes out of business, and then in 2015, the Falcon 4 CDs, which were originally sold in 1999, are so popular that they start selling them again, because everyone wants the CDs to use with the open source modifications. And then actually in 2015, they actually come out with a new version. So if you take a look at this URL here, if you're curious about the history. So this is a great example. The software goes from closed source to open source to closed source to open source again, which I think is really kind of interesting. This game is the longest developed computer game, period. Still in active development. If you go on YouTube and you put in Falcon 4, you can actually see the videos of the airplanes flying around and all of like very modern looking technology. Here's another sort of picture of how all this works. This is the picture of how software is developed inside of a company. Okay, so as you notice, the software is very structured. Like, hold on. You'll notice that all the development happens on the left-hand side. Okay, and then the users don't see it until it gets released. They're not involved in any of the early stages. Okay, they're not involved here at all. When it's released, it goes to the company, it goes to the people, and then they may find a problem, and then it has to go all the way back around to the top of the company again, and then walk through that whole thing. So this is incredibly inefficient. If you've ever had a problem with a piece of software and you send in a bug, and it takes like 9 months to fix it, this is why. Because this is a very inefficient process. Okay. This is the way open source works. The difference is that instead of everything happening separately inside a company and then separately for the users and the developers are communicating all the time. They're communicating when features are designed, they're communicating during patches, software patches, they're communicating during testing, they're communicating during release, and then even fixing bugs. This is incredibly efficient. Sometimes I'm asked as a Postgres person, how Oracle's $1 billion company, multi-billions, Microsoft's $1 billion companies, IBM $1 billion companies, right? Postgres has no money at all. So how does Postgres, which has no money at all, produce software that's as good or better in some areas than billion-dollar companies, right? You would think it's impossible. But it's because this is so inefficient that even with billions of dollars, it doesn't work as well as this. This is why Linux was able to work really well. This is why all that open source is now so popular. Because it's such an efficient way of doing development. Okay? Just to give you an example, when I'm developing a feature or I'm trying to fix a bug, I can have somebody in Krasnoyarsk help me. Right? I will tell you that when I had bugs in the first 5 years of Postgres, Vadim from Krasnoyarsk was my guy to fix when I had a bug I could not fix. I would ask him and he would figure it out. Okay, so that's just one example. But I had the ability to access so many people and get so many ideas. Like proposed features, we get a huge influx of ideas from the Russian developers about things that the Russians are really good at. And that gets funneled through the global discussion, and eventually it works its way all the way down to a released product, right? But companies can't do that. They can only use the employees that they hire. I can use anybody. We can use anybody. And that's really, I think, the key. Here's another example. When I started with Postgres, we were less reliable, had less performance, and had fewer features than closed source operating systems. So we were down here when I started. Oops. We were down here when I started. But the point is that our curve was always steeper than the closed source. So even though we started below, we were caught up faster. And we probably passed them at some point. Now you might think I'm kind of making this up. But I'll tell you, when I was a application programmer in the 1990s, all enterprises used operating systems, HPUX, AIX, and Solaris. Those were the big three. I used HPUX a lot. I used even VMS, if you're familiar with that. Okay. How many people are using these operating systems today? Not much. Solaris is end of life. Last year they stopped developing it. So that one's kind of gone. The other two are probably in stage 5. We're in maintenance mode. Okay? Why is that? That's because Linux was able to not only attain feature parity, or it's had the same features as these big billion-dollar developed operating systems, they were able to go past them. So the idea that you'd ever use these as your first operating system in a company is kind of ridiculous. Like, you may use it if you have to, but you don't start a new server and put this on. Because not only is it expensive, but it's not as good. Right? It's just not as good. Now you might think, okay, that's just Linux. But let's look at the database landscape. Okay? When I was a developer in the 90s, these were all the enterprise operating databases. Informix and Ingress, number 5 and 6, those are the ones I used the most. Okay? That was the big enterprise database. Those were it. Ingress and Informix are really not doing very well now. Including Sybase, they're probably in stage 5. Okay? They're just kind of limping along. They're going to, keep it running, and people will pay a little bit of money. I think Ingress may be in stage 6. It may be end of life. I don't know. I haven't looked recently. But my point is that 20 years ago, these were the dominant ones. Right? Now, number 1, 2, and 3 are still around. Right? But how many startups say, I'm going to make a new company, and I'm going to start on Oracle? Right? Not a whole lot anymore. Actually, they actually start on Postgres now. The majority of startups are starting on Postgres, if you look at the estimate. DB2 is still around. Microsoft SQL is around. Okay? But the point is that these are all kind of fading. They're not innovating anymore. They're in the stage 4 or 5 kind of case, right? Because they're closed source operating systems, and they kind of got to their saturation point, and then they just kind of code. Right? Exactly what I said. Postgres, because of the way it's developed, because it's developed all over the world, we're improving in multiple directions at the same time. So ease of use, cloud, NoSQL, big data, performance, scalability, compatibility, just a huge amount of stuff. Data warehouse, just all over the place. Postgres is improving. Every year, we have like 180 new features. Like, nobody's really improving at that speed. Why? Because the development process is not locked in a company, it's out in the world. And anyone who wants to improve it can get involved. And that's really powerful. So, just to summarize, proprietary software dies when the owner of the source code can no longer make any money from it. It's depressing, but that's how proprietary software dies. If I paid for all those developers to write that software, and then I can't make any money from it, then I stop. Unfortunately, it declines, proprietary software declines long before death because of that stage 4, that profit maximization where things get cut. And the service you used to have, the features they used to be doing, they stop doing so they can get more money. Okay? What's interesting is open source can't die in the same way. It doesn't have that death thing. Open source remains active as long as it serves a purpose. And it can always be resurrected if the software is found to be useful. And as I said before, in 1996, I was involved in helping to bring Postgres back and to make it popular again. It's kind of interesting. So it didn't die because the software was there. So, in summary, for this section, ideas don't die as long as they're shared, and ideas are shared as long as they're useful. And Postgres will live as long as it's useful. Will that be forever? I don't think so. Forever is like billions of years. No, it's kind of, no. But probably as long as I'm here, it'll probably still be growing. That's what I'm figuring. And probably Oleg too, right?
Yeah.
One little story related to this, I have 4 kids, and 3 of them are in college or gone to college, and they come back from college the first year or second year, and they say, hey, what did you think of Plato and the Cave, or Plato Symposium, or the Republic? Do you read Plato here probably, or no? Yes? Nobody reads Plato? Okay. Anyway, in the West, we read Plato, and Plato lived 2,600 years ago. But we're still reading his books, just like I'm sure you read books from Russian authors that are hundreds of years old. Why do we still do that? Because those people had ideas that are still useful to us today. That's why we read them, right? Doesn't matter how old it is. If the ideas are useful, we still read it. And that's in some way the way software works. As long as it has use, it continues to be shared, it continues to be useful. So, having explained sort of the open source life cycle, I want to talk about a survey, and I think this is getting a little closer to something that's going to be useful to you as engineers or as people are going to be going out into the world. Because, as I said before, people think of the way software was 10 years ago, 20 years ago. And they aren't thinking of how software is today. So a company did a survey in 2016, okay? And they surveyed all the people who are using open source software today. And this slide says, well, it's been 10 years, and so open source is incredibly popular, and so forth, okay? But this is a slide I think you need to understand. Almost everybody who chose open source software for their company did it to save money. Saving money was probably the number one reason people originally went to Linux, probably why they're going to Postgres, probably why they're going to a lot of open source things. Okay, Apache or whatever. Okay, saving money is incredibly motivating, but I attend like 40 or 50 conferences a year, okay? I don't attend 40 or 50 conferences a year for people who save money. Nobody has a conference about saving money. That you save money and then you go away. What you do have a conference about is when your technology is interesting and it allows people to do new things with their computers. That's why I have a conference. So what's really interesting about this slide is that when they polled everyone using open source and they said, what advantage, you might have chosen open source for cost, but now that you've been using open source, what advantages do you see in open source? The number one advantage was features and innovation. Number one, okay? They may have come to choose open source because of cost, but once they look back and they think of the advantages, number one advantage is competitive features and innovation. Then freedom from lock-in, so they don't have to worry about licenses as much. The quality of the software, the reliability, if you want to say. The ability to customize it. Then number 5 is cost. So really kind of surprising. People choose it for one reason, but then once they've chosen it, if they look backward, they see a whole bunch of advantages they didn't even realize. And this is sort of the cycle people are going through as organizations, where they're learning, hey, I'm using open source, what are my advantages? Like if I could allow somebody to use Solaris today, would you use it? Probably not. Like even if it was free, you still wouldn't use it. Even if you had to pay for Linux, you wouldn't use it. Even if it was cheaper than Linux, you probably still wouldn't use Solaris. Because it doesn't have any innovation. It's not going anywhere. It probably wouldn't even run on your hardware anymore. Right? I mean, that's terrible. So again, Linux grew because of cost, but people now go to Linux because of innovation and reliability and quality and customization and freedom of running on all sorts of hardware and so forth. Okay? The exact same thing is true for Postgres and a lot of other software out there. Okay? Open source really dominating operating systems, cloud, big data, Internet of Things, mobile. Pretty much all mobile is open source. In 2015, they did this survey, and databases weren't in the top 5. In 2016, they became in the top 5, so top 3. So, in fact, databases have become very big in the past 2 years, and you see a lot of growth really in this. So, a lot of conferences have been getting very popular in the past 2 years. Okay, so having talked about forever, having talked about software lifecycle, having talked about the open source survey and why people choose it, let me talk about Postgres innovation, because as I said in the previous section, people come to open source to save costs, but they stay with open source because of innovation. And as long as Postgres continues to innovate, it will continue to grow. Okay? Because it's one thing to choose Postgres because it's cheaper. It's another thing to choose Postgres because it's the only thing that actually does what I want it to do. And there's a whole bunch of areas I'm going to show you where none of the other databases really do what we do as well as we do. Right? And that's, I think, that's just true not only in Postgres, but other open source as well. They're not only cheaper, they're better. And I think that's a big, big, big issue. So, Oleg already talked about EF-COD, basically the concept of relational theory. So this is before Postgres. Postgres started in 1986. Michael Stonebreaker, I talked about this. And when he designed this, he designed it with extendability, the ability to add things to a database. That was a really new concept 30 years ago. And what it basically meant was you can add data types to Postgres, you can add indexing methods, you can add server-side languages, you can enhance the database really powerfully. So this is actually what the system tables look like in Postgres. And some of the system tables are pretty normal, but like the yellow ones are where you define your data types. So your data types are defined in the system tables. Your operators, the plus sign, the minus sign, the asterisks, are defined in the system tables. Your functions, your casts. In the blue on the right, all your indexing methods are defined in the system tables. Not in the binary, but in the system tables. Okay? And that extendability has been incredibly useful. For example, if I want to add some new data types to Postgres, I can say create extension and give it a name of an extension that contains some data types. So I do that part here in red, and all of a sudden you can see now I have 8 new data types that didn't exist before. Inside the database, they work just like the normal data types. Okay. If you want a server-side language, we support all of these server-side languages. Pretty much any language you're probably using, we have a server-side language for. If you need specialized indexing types, we have them. A lot of this work comes from our Russian team. You can see the second one, B-tree. That one's pretty much every relational system has B-tree. And hash, number 3. But Brin, what's that? Well, that's for data warehouse data warehouse uses. Gin and Gist, those are ideal for non-relational, NoSQL type of storage. Okay? SPGIST, even more specialized. So one of the great things about Postgres is that not only do we have the non-relational support, but we have the indexing behind it. And again, I have a slide, a URL right there at the bottom. That is an indexing presentation that you might find interesting. It talks about this. Okay?
You want blue?
What's this? We don't have blue, no, because it doesn't ship with Community Postgres. It will, hopefully, though. Full text search. This is, again, Oleg's team developed this, the idea of having a full text search engine inside the database. So instead of having to use Elasticsearch or Sphinx, you're doing the full text search in the same storage with the same transactions, the same indexing, the same joins as your actual relational data. That is very, very useful. And it has all sorts of features. It has stemming for certainly Russian and English and 13 other languages. In fact, I think we support 21 languages, somebody said.
Yeah.
Oh, and Postgres 12 will be 21 or 11.
Postgres 11.
11 is 21. So I have to fix this slide. Now that we've released
Postgres 12 even more.
Even more. So that's great. I will fix this slide tonight. We even have a trigram if you're searching for letters inside of words, not whole words, but like letters inside of words. So again, it's really interesting, and there's specialized indexing methods and operators and functions which support this specialized storage. Okay? Full transaction semantics. And here's an example. We're using a special gin index there. We have innovation in NoSQL, again, led by the Russian team. It allows you to mix structured and unstructured data in the same query, and it has specialized indexing operators and functions. Here's an example, looking for a keyword first name, a value of Jane, give me the last name, and of course it uses an index for that. Range types. This is the ability to store a start and stop field in a single field. It makes indexing of ranges very efficient. Again, very sophisticated indexing here. Here's an example. Give me the car rental that includes this particular point in time. And as you can see from the bottom, it's using a specialized index scan to do that on a gist index. Okay. Geometric types, points, lines, circles, polygons. We have all of those, and they work very well. Again, they can be indexed. This is another contribution from the Russian team, the ability to do nearest neighbor searches. This is usually very hard to do, but if I want to say, give me the two darts that are closest to the center, normally you have to make a box and then see if you then make the box bigger until you get enough points. With nearest neighbor search, we can walk through the index to get you those answers very quickly. Again, very few databases can do this. Very exciting. That's innovation, as I said before. GIS, if you're doing points on the globe or points in a city, and you need specialized processing that, we have a separate project called PostGIS that does GIS, plugs right into Postgres as an extension. And here's an example, computing the area of a specific geometric region in a city. Foreign data wrappers, this allows us to communicate to other data sources seamlessly. For example, I can write data to Oracle, I can read data from Oracle, I can write data from Mongo, I can read data from Mongo. I can even read data from Twitter if I want to. So I have the ability of taking a whole bunch of different data all over the place and kind of bringing it together in one place. Only Postgres does that, because again, we have over 100 of these foreign data wrappers. Data analytics, we've been working on this for probably 10 years. All these features that we've added over the years, just for data analytics. So you can do your data analytics and your transaction processing on the same server, or you can use streaming replication and use another version of Postgres and do the analytics there. It's up to you. And finally, the idea of having multiple servers for a database. We're working on this now. The idea of taking existing features of Postgres and effectively creating a server farm where you could have petabytes of data and store some segment of the data on several Postgres servers. But at the same time, people can send queries and they don't need to know where the data is. Again, this is innovation. This is taking Postgres to new data needs and making Postgres more useful for more workloads. So, to conclude, Postgres is BSD licensed. Oleg did talk about that. What that means is the source code is always available to anyone who wants it. And if you want to start a new project with Postgres, you're welcome to do that, even if you want to have it on a different license. And there's been, Oleg got an example, there's dozens of different closed source projects and open source projects which modify the Postgres source code. The development and leadership of Postgres is diversified, both geographically, culturally, and many, many companies involved, which is good. We have 32 years of development, 22 years of major releases every year, 180 features roughly per release. We do minor releases every quarter, and we are the most loved relational database. So, if you think I'm making all that up, this is a website right down here, okay? Which basically takes all the things happening in Postgres and puts them on one web screen. Okay? So we have the email traffic up here at the top. All the people who have talked about Postgres. Then the second section, all the developer traffic, the developer emails, the commits to the source tree, all of the current versions of Postgres, whether we're in a commit fest or not. You can look at the Git history of all those releases. And then the third blue block, the most current blog, the most current news item, the most current tweet, the most current mention in the media, and the most current event. And you just watch it. And then at the bottom, we have the IRC channel, which just rolls forward. And every time somebody says something, which is pretty much every 10 seconds or so, it scrolls by. And you can basically see that community working, and you can actually watch it. That's the cool part for me. Okay? So, what have I talked about? I've talked about open source innovation. I've talked about how the proprietary life cycle kind of dies in a bad way, but open source doesn't die. And it can always be resurrected. And I talked about how innovation is really the driving force behind open source. And as I said before, Postgres is in a really great position to be continually innovating. If you want to look at this presentation and look at these slides, you can go to my website right there, okay, and download these slides. There are also 25 other presentations on this website, including videos. So if you want to watch a video of me talking again on a different topic, feel free to go to the website and take a look. I know it's getting late. We promised to finish by 6, and I want to thank everybody. I will be here for questions, but I think based on the time, we're just going to stop it here. I think we've had a really great event. It's been a lot of excitement. I thank you for sort of holding to the end. I know it's hard, but hopefully we'll be able to do it again, and hopefully you found that this was a very good use of your time, and that you felt that that you learned something useful here. So thanks very much.
Ну, в общем, все поняли, да, что Postgres будет жить до тех пор, пока Postgres будет развиваться.
Полезно. Пока он будет полезен.
Будет развиваться, да. Да. И развивается он от того, как жизнь требует, да. То есть, поэтому он будет жить вечно. Потому что у нас всегда будут какие-то надежды на то, что тут требовать будут люди, делать что-то новое. Мы будем стараться. То есть не нужен диалог. Вопросы? Брюсу. Может, у кого-то есть какой-то? Давай. Брюс, one question.
No, but it's late. Everyone wants to go home. You should all want to go home. What's the matter?
Bruce,
Yes.
have you ever had a situation, or do you think that someone may get into trouble in which a commercial company takes his ideas and his innovations and makes money?
That's a great question. So the question is, would you ever get in a situation where you spend a lot of time innovating, and then some company takes it and then makes money off that innovation? I think that's the question. Is that right?
Yeah.
Yeah. So the bad news is that happens all the time. So you might remember Oleg's slide where he had, I think it was 2003 in the left-hand side, and he had a whole bunch of green and red dots that went across. And one was a luster. I mean, no, one was green plum, and one was aurora, and he had a whole bunch of charts. So the bad news is that our innovations are taken by companies all the time, and there must be 20 different ones. Vertica was one you listed. So there's a whole bunch of companies which love the Postgres source code, but they want to do something different with it. They want to make it massively parallel. They want to make it work on special hardware. They want to sell an enhanced version of it for whatever reason. And we can't stop that because the license allows those companies to take the source code and make money. Okay. Now that sounds really bad. It does. Okay. But the good news is that for every company that takes the source code and makes money off it and never helps us, there's another company which takes the source code, makes money off us, and then comes back and helps us. Okay? So my company, I work for Enterprise DB. I've been with them for 12 years. They've paid me for 12 years to do basically what you're seeing right here. They've paid me to write presentations and work in the community and go to events and help make Postgres good because their business is built around the technology that Postgres produces. Oleg's company, Postgres Professional, right? Yvonne, Oleg, they both work there. Their company is making money from Postgres, but at the same time, they're funding a whole lot of developers who are helping us every single day. Like I bet if I go back to this slide, no, sometimes I can actually see somebody's name in here and I say, oh, that's somebody from that company. So the good news is that some people are going to take the source code and make money off it and never help us. But there's enough of the companies who actually want to help us. Even Amazon, to some extent, is wanting to help us. Pivotal, Greenplum helps us. NTT helps us. Fujitsu helps us. NEC helps us. We have a lot of the banks in New York help us. So there's a lot of those companies who are making money from us, but they also want to see Postgres grow. They want to see Postgres get better, and they know that their business is only as good as Postgres is good.
So you both benefit from it.
Exactly. We both benefit from it. You would think it would not work, but as long as Postgres is this vibrant, powerful, energized community, these companies can't do that. They don't have an Oleg and a Vadim and Yvonne and Alexander. They don't have our team. And they can't get our team because our team are some of the best developers in relational databases in the entire world are on our team. Okay? Oracle has a small number. IBM has an even smaller number. Microsoft has a number. Okay? We have thousands. Okay? I've got thousands of people. And I know somebody in Krasnoyarsk is going to help me in my problem. Right? Or somebody in China, Alibaba is it's going to be helping with Postgres a lot too. So it's really interesting. You would think they would never help you. They just make the money and leave. But because we're so good at what we do, they know that their success, for them to be successful, we have to be successful. And I think Postgres Pro feels the same way, that when I talk to Enterprise DB, they're like, you worry about the community because we need that community healthy. We need that community improving every year. We need the new features from the Russian developers. We need the new features from a lot of your people. And if Enterprise DB doesn't get them, and Postgres Pro doesn't get them, and Amazon doesn't get them, and VMware doesn't get them, and all those other companies, then they're going to be stuck. So they're always feeding back. They may make millions of dollars off of us, but if they just give back a little bit and everyone does that, we do very well. Yeah, and we have a lot. We have. I'll give you the weird example. When I started with Oleg, we were all volunteers, so nobody paid us. So we had to do this on our weekends, right? So in like 1999, I was like fixing things on the like an hour in the morning. I'd work very hard, and then I had to go to work, right? So I'd like fix something in an hour, but if it took 4 hours, I couldn't fix it. So I'd call Vadim and I'd say, "Can you look at this?" And then he'd fix it overnight or something. But the point is that when we were all volunteers, it was very hard for us to invest days or years into some of these features. And we kind of, even, you remember probably in 2004, 2003, we kind of got stuck because we were all volunteers. We all had jobs. And some of the features that we needed were going to take a year to develop. I can't stop working for a year. No, you can't stop working for a year. So you kind of scramble and you put in a couple long weekends, but still it was really hard. Once the company started contributing developers to us, as Postgres Pro does, as Enterprise DB does, as Second Quadrant, Creditive, Crunchy Data, who are the other ones? There's just Cybertech, there's a lot of them, okay? Once we started getting full-time developers on volunteering, all of a sudden we could do some of these really hard things because they had a year to work on it. So in fact, without those companies, without their making money off of Postgres would not be where it is today. And I think it's surprising to me. You would think that would not work. You would think that people would just worry about making money and they would never give. Enterprise DB gives years of developer time every year. And I know Postgres Pro does the same thing. Years of developer time every year. So how many developer years do you give in a year? Do you know? 8, 10?
About 20?
20.
Yes.
15. Okay. Enterprise DB, we probably give something very similar. So that's like really good. Plus, those 30 people between the two companies are getting ideas from everywhere. So they might be working on for 15 years in a year, 15 people, but they're getting ideas from people in China and people in Latin America and Chile and Canada and US and Europe. And so they're developing, but they've got this stream of thousands of people giving them like new ideas of what to do. And you become amazingly good when you have somebody like helping you like that. When I develop a patch, I'll spend a week on it and I'll post it, and then 8 people will find mistakes, right? But that's great because I didn't have to find those mistakes. Those 8 people found the mistakes before we even put the code into them. They found them right away. Sometimes it's Oleg who finds it, or Theodore who finds it. So they find the mistakes very early because even though I'm only one person, I have these thousands of people watching me all the time. And incredibly powerful. You would think it would not work, but it does.
It reminds me of Linux storage.
Right, very similar, very similar.
Okay, thank you.
Of course.
Ну еще чего. Хочу сказать, что Брюс очень хорошо сейчас все рассказал, прям и про мою жизнь, и про его жизнь. Вот, но хочу сразу вам сказать, что когда я был бесплатным рабочим в Postgres, ну то есть я по вечерам работал, мне работалось, конечно, легче. То есть я приходил после работы, садился, и вот как бы Postgres для меня был как отдушина от тяжелой жизни. Была перестройка, там вот вся эта жизнь, а мы продолжали делать, просто мне хотелось это сделать. Вот я призываю вас, пока вы молодые, пока вы можете потратить время на что-то не очень платное, например, на Postgres, попробуйте, сделайте какой-нибудь патчик, сделайте какой-нибудь contribution, вам выдадут благодарность. У нас, знаете, благодарность в нашем мире как делается? Когда вы делаете git-log, и там ваша фамилия. И вот тогда вы будете ходить просто, знаете, с счастливой улыбкой, да, и говорить всем, что у меня есть комит в Postgres, платите мне побольше денег и так далее. То есть попробуйте, это же все делается, же все обычные люди. Вот я говорю, что я свой почти все. Вот, был такой же. Просто в какой-то момент мне захотелось интересно и сделать что-то такое полезное, да? Postgres, он дает вам возможность просто, не просто только кодить. И даже то, что вы найдете ошибку, да, повалите Postgres и пришлете письмо грамотное от Postgres, да, это будет уже помощь. Не просто пришлете, что у меня ничего не работает, а именно анализ сделаете. Это все равно вот то, что вас учат, да, вот уже будет польза. Это как раз и есть, вот, благодаря чему Postgres развивается. У нас миллионы тестеров. Люди, значит, тестируют, проверяют и так далее. Не все могут кодировать. Но вы можете написать статью. Вы можете взять документацию, например, да, и написать ее получше. Потому что, честно скажу, я там 5 глав написал, но я такой писатель, вот, что мне не очень это нравится. А кто-то, например, может взять и лучше написать. С точки зрения пользователя, например. Потому что мы пишем все сознанием внутри. Ну и куча других способов, например, помочь конференции. В следующем году будем проводить конференцию здесь. Помогайте. Помогать конференции, там, пиарить, программу создавать. Вот есть вот такая работа, например, совершенно, вот кто сейчас найдется, да, прямо мы с Евгением сразу же возьмем на работу, как говорится, заниматься этим делом. У нас на YouTube есть канал Postgres Professional. У нас там, наверное, уже около сотни лекций скоплено. Лекции по курсам, вот то, что вы будете слушать, DBA1, DBA2, DBA3 и так далее. Вы возьмите, помогите, приведите их в форму книг. Форму книжек. То есть мы, как говорится, да, вот Егор автор, именно, он сейчас скривил лицо, но это тоже будет полезно. По крайней мере, надо, потом это можно отредактировать, привести в вид, и будут какие-то книжки. Ну, то есть я говорю, что форум по помощи open source масса. И для этого не надо быть обязательно программистом, знать C, значит, и рвать на себе волосы. Просто кайфуйте. Давай, спасибо.
You're right. It's exactly the same as Linux. Oops. It's exactly the same as Linux, and we get 3 or 4 patches a week that correct the grammar of the comments in the source code.
Да, да. Потому что часто мы пишем, вот из России, мы пишем такие комментарии с ошибками, там, иногда будет вообще бывает интересные всякие.
So that's the level of expertise that we have. If you look at the source code, it is so amazingly easy to read because we have to make it easy for people to learn. But that's the level of detail. When you have tens of thousands of people looking at the code, even little things do get corrected. Yeah, it's very exciting. And also Linux, that's a great example because you're right. Many people are making money on Linux, but IBM, Intel, how many companies are contributing to Linux? Probably too many for us to even remember them all. It's a great example. We had a question up here. Yes, sir.
So, you mentioned that the proprietary software has an end of life. So, it's a problem. So, at the end of life, many of the owners of the actual software pieces are not getting any more money after this point. So why don't they make it open source?
You know so the question is, I'm just repeating in case people didn't hear. The question is, when software reaches this stage 6, right?
Maybe stage 5.
We're stage 5. Why are they not releasing the source code? So the answer is, there are a small number of companies that do it, but the depressing reason they don't do it is because there's no money to be made by doing it. And there is embarrassment by doing it. So most proprietary source code is incredibly ugly.
Ugly.
I mean, I was talking to this gentleman about correcting comments, right? I mean, the problems of this source code go way beyond the comment problem, right? I mean, they're just throwing in stuff as quickly as they can to get it shipped to get more money in the company. Because again, the revenue is, and this is, I find this depressing, but the revenue is driving those developers. It's driving the features they add, It's driving everything they do. And when that happens, the code becomes incredibly ugly. Even Oracle, I've heard, is like really not something you want to look at. And I think it's really out of embarrassment for the developers that they don't do it. And it is sad, because you would think that it should be easy to do, particularly computer games, which I would think after a couple years you could release and then somebody could make a new game out of it. I thought it would be kind of nice, but it doesn't happen. I wish it happened more, but there's no financial incentive. The source code, is locked away in the company, and then the company goes to end of life, but it's still owned by the company, and maybe they'll bring it out again, but then it goes bankrupt, and then somebody buys the source code from the bankruptcy, and then, it's just depressing. I really wish there was some law that said, you just got to do it, and that would fix it, but I don't know. I've always wondered the same question. The software industry would be so much better if there was some way to make that happen, because we could learn so much, I think, from these things, from looking at the code.
Что вы все знаете код вашей компании, и попробуйте сколько надо труда, да, чтобы выложить и не опозориться. Поэтому вот исходники Postgres, вот чтобы пройти туда, пролезть, да, вы пройдете через все горнило. Вас будут чесать, ревьюить, отказываться. Я знаю вот мои несколько, вот скажем, тот самый КНН, ближайших соседей, если кто не знает, это офигенная штука. Мы пропихили 3 года патчи, 3 года. А вот некоторые у нас есть и по 8 лет патчи. Просто очень тяжело пройти на идейном уровне, на уровне имплементации, реализации и так далее. Вот, то есть это проходит, то это, конечно, баги остаются, но в целом, конечно, это сильно лучше, потому что выставляется на мир, любой может посмотреть, а потом тебе подойти на улицу и сказать, гад, ты такую херню написал.
Самый тяжелый код-ревью, наверное, да?
Код-ревью, да. Кстати, вот вы можете код-ревью заняться, потренироваться. Для этого вам все-таки самим надо что-то знать.
I'll give you another depressing story. So, Oleg's team was responsible for JSON-B, which was the new JSON data type that exceeded the performance of Mongo, and really a breakthrough. I remember when they announced it, breakthrough data type for Postgres. And we were set to release in September. And in August, somebody from Russia noticed that the compression of the JSON-B data type was not as good as it could be. And I remember looking at that email, and 2 weeks went by, and nobody said anything. And I replied, and I said, folks, I think this is a problem. This person is probably accurate, because he had a whole bunch of tests that he did. I said, this may be a problem. So we started looking at it, and we realized that the structure of the way we put the JSON elements in the data type reduced the amount of compression, because the duplicates were far away. And to do compression, well, you want to have them near each other, right? So we're like, okay, we're supposed to release in 2 weeks, and we've got this problem, right? And it's very hard to fix, because once you release it, you do in-place upgrades, so the data structure's fixed. I mean, it's very hard to change. So we're like, okay, Oleg, Theodore, Alexander, look at this. I think it was Theodore who looked at it. It's like, the way Theodore, yeah, that's right, it's a problem, this is really bad. So we're like, okay. Turns out we didn't release till January. So we delayed that release for 4 months while we restructured this JSON-B data type. And when I told my boss in September, he said, where are we on the release? And I'm like, well, I said, we kind of had a problem. And I showed him the email, and he's like, it looks like we're going to be delayed for maybe a couple months. He's like, a couple months? He's like, we have customers who are waiting for this. And I'm like, yeah, I know. He said, well, this could affect the quarter. I remember him actually using those words. This could affect the quarter. Like, we have deals riding. I was like, well, I said, Mark, once we release the data format, it's really hard to change it, like, later. So we got to get it right, He's like, I don't know. I said, I think you're making a big mistake by delaying this. People are really wanting this thing, and you got to get it out. And I'm like, well, Mark, I said, I agree with the community. I said, this isn't going out until we get this right. So released in January, and he wasn't happy. He kind of like, can't you do anything? And I'm like, no, I'm not going to do anything because I think we're doing the right thing here, right? Like, I'm not even going to consider helping you, boss. And like 6 months later, he said, he said, when I talked to you like 6 months ago, I was really upset because I'm telling you what I'm hoping you're doing, and you're basically saying no. And he said, I thought that we made a huge mistake, that we lost an opportunity to use this data type for 4 months. But he said, now that we're 6 months farther, he said, I can see the wisdom of what you did, because for the next 10 years, we'll benefit, or until this data format changes, we'll benefit from that 4-month delay, right? And the only reason we're able to do that is the community said, we don't care. We don't care if you lose money. We don't care if you're waiting for this feature. One of the big differences between Postgres and other databases is that Postgres is designed by engineers. It's not designed by the salespeople or the marketing people or anyone else, right? So the decisions are made by engineers, the design is by engineers. So you have a very holistic, a very well-structured, and a very easy to use, high reliable system, because it doesn't have pressures to get stuff out and just get it done and whatever. We're very meticulous. It takes longer to do stuff in Postgres, I think. Our development process takes longer, but the result is of such high quality that effectively we've I think are going to take the market. Somebody asked me in the last, again, I'm on a 27-day trip, and I think with Lisbon, which is where I started this whole trip, somebody asked me, they said, will Postgres be the dominant database in 5 or 10 years? I said, I can't really predict that, but I can't imagine what other database would be the dominant database except Postgres. I can't imagine it's going to be Oracle or DB2 or Microsoft. It's not going to be MySQL. It's not going to be MariaDB. It's not going to be Mongo. It's not going to be Cassandra. Like, what's it going to be? Well, it could be a brand new relational database that appears next month, but being 32 years in, I don't think that's likely. So I think it's likely, I guess, Postgres will be the Linux of, databases. I don't know, but I don't know who else it's going to be if it's not us. It's kind of an interesting question.
I see, thanks.
Great.
Yes, I remember the story about JSON-D. Actually, everything was working fine, fast, but like just small header. Yeah, and so many people start discussing this. And help. We checked many variants, many algorithms, and finally we found some which everybody accepted.
Yeah, I remember we basically gave them a report, and they're looking at it, they're like, oh my God, you think you're almost done, and then you're right. His team had to spend days or weeks on this thing, trying all sorts of different things to make it as good, as perfect as possible. And everyone, thousands of people are all saying, oh, you should do this, and you should do that, and no, we can't do that, because this will happen, and all of a sudden, every decision they've made has to be relitigated, because they made the compression. You don't think about compression sometimes or they thought about it but didn't realize what was happening maybe in the structure. But I think it's a great example of those thousands of people studying, looking at. I mean, we're so glad they saw it before we released it. But we were in beta, and it was hard. It was hard. I remember talking to you and saying, oh, you know, you got to fix this. And it took them a long time. You weren't even happy about it. You were like, oh my goodness, how long can I spend on this thing? But now it's a shining feature of Postgres. I mean, you're glad you spent the time, right?
Yeah.
Yeah.
This is example of democracy
Yeah.
of our community. The problem with the democracy is that you can work for 1-2 years and you want to features committed, but and almost everybody agree, but then somebody come, I even don't know,
Never heard
and
of them
say,
before.
oh, I don't know, is it good? And then discussion start again.
Yeah.
That's the problem.
The person in Russia who found the compression, I don't think we had ever heard of him before. No, we'd never heard of this guy. And that's why he got ignored, frankly. Like, I go through the email list and I try and look to make sure everyone got an answer. And I remember saying, this person has not gotten an answer, and it looks like a problem. And that's when we had never heard of this before. I don't even remember the guy's name. But I've never heard of him before. But I thank him if I ever meet him.
Such a story and no name for it.
Yeah. We thank him, because if he wasn't there, it would have been impossible to fix later. But the compression was dramatically better once they re-engineered it. It made a big difference. It really was. It wasn't a small little number. It was big.
Еще вопросы?
Yeah.
I can say there is a fact the proof you was about power of open source development that even Microsoft, such proprietary software company, commercial company, decided to develop the new framework .NET Core as open source, and they are doing it now.
So the gentleman was saying that even Microsoft now is touting open source. An even better example of that is that all the cloud companies are promoting Postgres. So Microsoft's a great example. So we have a conference in San Francisco every year. And last year I went to the conference, and I'm here, Microsoft wants to meet with you. So I'm like, okay, I'll go meet with them. And we have a lunch, and they say, what can Microsoft do to help Postgres? And I'm like, okay. I said, this is a $1 billion company, and they're asking me as a community member, what can we do to like. Normally, when you have a huge company, all the little companies like, oh, I want to do business with them. I want to be a partner or whatever. And here I have this huge company coming to me or a community and saying, how can we help you? Because there's such a sense from all these big companies that open source is the way to do things and so efficient. Another example is IBM. So IBM has DB2, right? Microsoft has MS SQL. I do sales seminars for IBM equipment. So the Power 8 equipment, the Power series. Postgres runs great on the Power series. So all the IBM people who are selling Power say, can you come and do a seminar with us and talk about Postgres and how good it is on our Power architecture? I'm like, okay, but I said, you know you have a database of your own, right? And they said, we know, but we just want to sell the Power equipment, and the DB2 is not as good. It's kind of hard to use. So we're going to whether it's Microsoft or Google or IBM or pretty much any of the cloud providers, they're all trying to figure out not only how to use Postgres, but even to the point of how can I help the community? How can I give back and make Postgres even stronger, which is great. Yeah.